Now that we know how to graph an equation in polar form, like r of theta is equal to cosine 2 theta, we know that it has a direction. So when theta is 0, we start here, and then we can go around. In this case, it makes this kind of nice floral pattern, right? Let's take a look at what that would look like in Cartesian form. Now, if I want to change this equation into the Cartesian coordinate form, right, it means I have to change this to x's and y's, and that when I plot it, it's got to give me this nice floral shape. Now, however, this floral shape is not a function. So we're going to have to really see what this turns out to be. Now, I will give you a warning that this is not the easiest of problems. So we're diving right in here. We know that x is equal to r cosine theta, and we know that y is equal to r sine of theta, and we know that x squared plus y squared is equal to r squared. Now really, it's a big puzzle. All you're really doing is anytime you see an r, you want to somehow get it out and replace it with an x and a y. Anytime you see a theta, you want to get it out and replace it with x and y. So I'm going to rewrite this not in function form, but just like this. Cosine of 2 theta, it doesn't look like I have anything very readily available. So I'm going to change this use the trig identity to change it into cosine squared theta minus sine squared theta. Now it looks like I have a cosine theta and a sine theta and an r. So cosine theta I can solve for here. I get x over r. And sine theta I can solve for here and get y over r. So in this case, what does that mean? It means cosine theta squared is going to give me x over r squared minus sine of theta y over r squared. Now in this case, r is equal to x squared minus y squared all over r squared. We're getting close. We're getting close because we no longer have thetas, now we only have r's. From here, it looks like I have r cubed is equal to x squared minus y squared. Now, r squared is going to equal to x squared plus y squared. And r is going to equal to plus or minus square root of x squared plus y squared. So it looks like I have, well, r squared right here, for example, I can change it. Actually, let's try that. I can change it to x squared plus y squared. And here I'm left with square root of x squared plus y squared, plus or minus. Now again, this is important because we already know that this function is not going to be this function of r polar function is not going to be a function when we change it to Cartesian. Now, how do I write this a little bit better maybe? Maybe square root, maybe it'll be x squared plus y squared. It'll be to the 3/2 over here. But this will still be plus or minus. So what I'm going to do here is I'm going to try to square both sides, and I'm going to write this is equal to this. And now I have all my pluses and minuses are taken care of because this inside is automatically assumed to be plus or minus, and the cubic won't matter on this side. How do I verify that this is exactly the same thing as this? Right? If I graph this polar, we already know what it looks like. But what happens when I graph this in Cartesian? Now on our graphing calculators, I would have to solve for y, and that's no fun. Nor I don't even think it's possible. So then in this case, what I'm going to do instead is I'm going to go to the internet to our free doesmost.com. And from here, we can actually type in the equation exactly the way we want it without having to solve for y. So it's x squared plus y squared to the third power is equal to x squared minus y squared to the second power. X squared minus y squared to the second power. And voila, we have our exact same graph, except in Cartesian form. So now that one was pretty difficult. Let's try one more example. If we have something like r squared is equal to 9 of sine of 2 theta. Now again, r squared is pretty easy to replace. It's going to be x squared plus y squared. We have 9, but sine of 2 theta, I don't see sine of 2 theta. It's a double angle again, so I'm going to use my identity and change it to 2 sine theta cosine theta. So I'll be left with 18 sine theta cosine theta. Now again, sine theta is going to be y over r, and cosine theta is going to be x over r. So then I'm left with x squared plus y squared is equal to 18xy over r squared. And r squared, there it is again, I'm going to replace with the x squared plus y squared. So in this case, really what I'm getting is x squared plus y squared squared, and it's going to equal to 18xy. And that's it.